Q7097-2. What should be the first step in correcting pilot-induced oscillation in a gyroplane? A. Reduce power. B. Establish a climb. C. Apply positive forward cyclic. The correct answer is A. When encountering pilot-induced oscillation, PIO, in a gyroplane, the first step in correcting it is to reduce power. Pilot-induced oscillation refers to an unstable condition where the gyroplane's response to control inputs becomes exaggerated and oscillatory. It can occur when the pilot overreacts or provides incorrect control inputs, leading to a cycle of corrective actions that amplify the oscillations rather than dampen them. By reducing power, the overall thrust or force being generated by the engine is decreased. This reduction in power helps to decrease the energy input into the system, making it easier for the pilot to regain control and stabilize the gyroplane. Lowering the power allows the gyroplane to settle and reduces the effects of excessive control inputs. It gives the pilot more opportunity to correct the oscillations by applying appropriate control inputs without aggravating the situation. Reducing power is an effective way to mitigate the oscillations and regain control of the gyroplane. It provides a more stable platform for the pilot to assess the situation and make further corrective actions if necessary. In summary, reducing power is the recommended first step in correcting pilot-induced oscillation in a gyroplane. It helps to decrease the energy input and allows the pilot to regain control and stabilize the gyroplane before considering other corrective actions. Q7097-3. Which pilot action will help reduce pilot-induced oscillation in a gyroplane? A. Avoid flight at high speeds. B. Increase power if nose pitches down. C. Prior to a climb, increase pitch attitude before increasing power. The correct answer is A. To reduce pilot-induced oscillation, PIO, in a gyroplane, the pilot should take specific actions to stabilize the aircraft and prevent further oscillations. In the case of PIO, it is important to recognize that the pilot's inputs or disturbances are causing the oscillations. To mitigate this, the pilot should make appropriate adjustments to regain control and stabilize the aircraft. One effective action is to reduce power. By reducing power, the gyroplane's thrust and speed decrease, which in turn reduces the dynamic forces and aerodynamic effects. This helps to stabilize the aircraft and dampen the oscillations. Reducing power reduces the overall responsiveness of the aircraft to control inputs, making it easier for the pilot to regain control and prevent further oscillations. On the other hand, options that involve increasing power if nose pitches down or making specific control inputs, such as applying positive forward cyclic, may not address the root cause of the oscillations and could potentially exacerbate the situation. Therefore, the recommended action to reduce pilot-induced oscillation in a gyroplane is to reduce power. This allows the pilot to regain control, stabilize the aircraft, and prevent further oscillations. Q7097-4. What should be the first action taken if a gyroplane begins to oscillate in flight? A. Reduce power. B. Unload rotor system. C. Apply aft cyclic pressure to increase pitch and reduce airspeed. The correct answer is A. To address oscillations in a gyroplane during flight, the first action that should be taken is to reduce power. When a gyroplane starts to oscillate, it usually indicates an unstable flight condition. Reducing power helps to mitigate the oscillations by reducing the overall thrust and speed of the aircraft. By reducing power, the dynamic forces acting on the aircraft are decreased, allowing the gyroplane to regain stability. The reduction in power reduces the responsiveness of the aircraft to control inputs, making it easier for the pilot to regain control and dampen the oscillations. It helps to prevent further exacerbation of the oscillations and allows the pilot to stabilize the aircraft. In contrast, options that involve unloading the rotor system or applying aft cyclic pressure to increase pitch and reduce airspeed may not directly address the root cause of the oscillations and could potentially worsen the situation. Therefore, The recommended first action to take if a gyroplane begins to oscillate in flight is to reduce power. This enables the pilot to regain control and stabilize the aircraft, ensuring a safe and controlled flight. 7097-5, which will help prevent pilot-induced oscillation in a gyroplane. A. Adding a horizontal point of reference. B. Decreasing loading on the rotor blades. C. Raising the center of thrust above the center of fuselage drag. The correct answer is A. To prevent pilot-induced oscillation in a gyroplane, one effective measure is to add a horizontal point of reference. Pilot-induced oscillation, PIO, occurs when the pilot's control inputs inadvertently result in a feedback loop between the aircraft's response and subsequent control inputs. This can lead to unstable oscillations that are difficult to dampen or control. By adding a horizontal point of reference, such as a visible line or instrument, the pilot gains a visual cue for maintaining a steady and stable flight path. This reference point helps the pilot to detect any deviations and make corrective inputs in a more precise and controlled manner. The addition of a horizontal point of reference provides a visual aid for the pilot to gauge the aircraft's attitude and maintain a stable flight path. It helps to minimize the tendency for overcorrection or erratic control inputs that can trigger or exacerbate PIO. Options such as decreasing loading on the rotor blades or raising the center of thrust above the center of fuselage drag may not directly address the issue of pilot-induced oscillation and may have other effects on the aircraft's performance. Therefore, adding a horizontal point of reference is a recommended approach to help prevent pilot-induced oscillation in a gyroplane. It enhances pilot awareness, improves control precision, and promotes a smoother and more stable flight. 6603-2. Gyroplanes that use small wings will cause rotor drag to do what at higher cruise airspeeds? A. Increase. B. Decrease. C. Remain the same. The correct answer is B. When gyroplanes that use small wings operate at higher cruise airspeeds, the rotor drag will decrease. In a gyroplane, the main source of lift is provided by the rotor system, which consists of rotating blades. The rotor blades generate both lift and drag as they rotate through the air. The lift produced by the rotor system supports the weight of the gyroplane, while the drag opposes the forward motion of the aircraft. When gyroplanes utilize small wings, these wings primarily serve to provide additional lift and stability rather than significant aerodynamic support. Therefore, the wings contribute a relatively smaller portion to the overall drag of the aircraft compared to the rotor system. At higher cruise airspeeds, the airflow over the rotor blades increases, resulting in a higher relative wind speed. This increased airflow helps to reduce the angle of attack of the rotor blades, which in turn reduces the drag produced by the rotor system. As a result, the rotor drags decreases at higher cruise airspeeds. It's worth noting that while the rotor drags decreases, other forms of drag, such as parasite drag from the fuselage and wings, may become more significant at higher speeds. However, in the context of the given question, the focus is on the specific effect of small wings on rotor drag, which decreases at higher cruise airspeeds.